Calling ambulo luku with whatever we do. Jioni safu no la with whatever we do. Hale yide munyu skula nyepamne ne kudlukula nyepangi ragala gena nyepamne ne kudlukula ibuloke nongoto ibeti sola ibuloke dato ni betoto
Bege Congo
Lamin
na
Lamin te jibe norin te nyamen Lamin
kabana wulo kono
nyinta mo Lamin
pabilenki
muna ngata afamole
hayna
ngata ngoto le Fabrama
Mingi baba nyola
no ngoto le Fabrama
no mo jumara kan kuma diten
Fabrama
jumara mu
ndele bare muso
nunda mana
kata
jamani mbere
lindo ko
jamani
bari ngoto man kontande
bari jamani bana na mu do kontan
ngoto minaka ngala min de fon filitala Lamin jibe nori nyaala
Lamin ila siran sama ne benki yala so dol sayni no bo mo lokko momo
ngoto
nam
iterinte yalo ne Lamin hakkilo diata bake karamngoto anu santen ministry ko di ngole si suko amake ko do holi
si bitun
bagona de ngam
ala ni ko de namo balo
ala ne na ko na karta bulo be dam ala nije
ngoto
nam
ngoto mon kontan fere
jamani mu ne keda
ke Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasi ka wulo ko no ko
baba
karamol ma ni ko karamol sorande amake ko holiday lem ngoto dini wonyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda la kombo ndo la jankara mol soranda do kamen courant ma rado la kombo ko ndo fana na karam mol soranda Lamin ada lo nyino la man dara fe na so kon ala mu nekela
Lamin ite fede malo ko le sinol de ke kar radio to
nga fine
e ko yana mo Lamin
nga fine
ya mo na fonye
mi tabin mina kan tambita nteri maning Fatu
ha
tambite la suko ala dinol bebe siri be la moy ka
faru dan so am fanan kamira jere ni subala la ngaje dinol be jet talanta nen kili waro e be seri jelet
sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo ala
dara fenela
ite dine ko ni man su yakari la sino la moy radio to e balon nan
mo ne ka ke afende ma nyaara ni alon
kelentel jikot
afende ma mo de ke
ite balentel be jikritel ni man karam me ku kele yaaje nata karana mbasa malaya ay tarije
bar ñarande kombo courant o findira kombo ile nara yede ni sonka bay ko Lamin ma ñata la wulo ko kara mo be so da fa ñambe
ko to wole nati bayo ngalle ni Lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulan koto batiri sanga ay si ay alamo
sa do kala
nyaadi ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio ado la mo la be mo na falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karam
ile subject o baby jele baby jele
wala nan ka toto moy fa dan so wala ngomme tambi kana ngadi ngol de be ikadum bu ko de kala
ma asototal de
Lamin mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
mo ne ko di ko de ko folle sinila ba ndele sinilo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yin fana bulata ko ko do meyen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bula kara wulo kana ta kilar ya bambalo yo be bula je koto dinni ngoy si ayala le sino la moy radio
wala ga munda kara mo man soro Lamin nyanta kara si suwa na
radio sino le ayala le sino
dal ko korno ko smalo
kilar ya
be bi ko mo sa mi do ni ko no kera
nengi bruzo
am le ko la da baro sa no radio ba no bari woro radio ni abe je le baro ngamra do man be buljan dala nyara nyar woro ko fendi mo la Lamin tayra ba do sa
bara ke ku folo ajibe nori nya labi tamete
muna na de
teku
bari ko do famo ke
ja image nani nyambol si zol le ke je kisgi man si zol no le kamun ka nyowa bari nyambu kino ni manya na ka finde ni nambe ko zol la ga ni nambe ko zol la ga
ngalle limbe tambo do dilanna
nyara ni ko rim fennat nyara nata
bari famo ke da
nata bu ngono tabi bu ngono nyara ngando ko mele ko ke de bar ngam ni pelo la dija
iyo
awata bismillah di sudiara
pendulala yefungo tanka sina dulu tanka koro ta koro
Hello viewers and listeners, we welcome you again to another lesson of the upper basic component, and today we'll be looking at inequalities. So but before we start our lesson proper, there were assignments that were given in the previous lesson, and I would like to get you through to those assignments, and those assignments also serve as a prerequisite to what we'll be doing today, to our inequality lesson. Now here the first assignment that we have is evaluate the expression for A equals to 2 and B equals to 6. And the expression given there is B minus A. Evaluate the expression for A equals to 2 and B equals 6. Now the expression that is given is B minus 6. Now when A equals to 2 and B equals 6, you are asked to subtract A from B. And this will be, we substitute the values of A and B. B is 6 and A is 2. This will lead to our answer, which is 6 minus 2, 4. This was our first assignment. And our second assignment was also an expression. Simplify the expression 3 minus D all multiplied by 5. In other words, we have 5 outside the bracket, and we have to multiply whatever is inside the bracket by 5. We have to solve this expression by multiplying all the terms or the variables that are inside the bracket by 5, which is outside the bracket. So this would be 5 times 3 minus 5 times D. 5 times 3 is 15 minus 5 times D is 5D. Therefore, our answer is 15 minus 5D. And this happened to be option B, 15 minus 5D. Now let's talk about our third assignment here. And our third assignment was solve R minus 8 is equal to 13. R minus 8 is equal to 13. Let us solve this together. R minus 8 is equal to negative 13. Negative 13, not 13 actually. So in solving this, all we need to do is we need to isolate our variable, meaning our variable should be on one side of the equation alone. In doing so, in trying to isolate our variable, we must undo the term or the coefficient that is there with the variable. How can we do this? We have a negative 8. We need to undo the negative 8. How do we undo the negative 8? By using its additive inverse. When we add 8 to negative 8, that will undo the negative 8. And because we added 8 on the left hand side of the equation, we must add 8 onto the right hand side of the equation as well. So we will finally have R, this will cancel out because it's 0, is equal to negative 13 plus 8, which will be negative 5. So R therefore equals to negative 5. Now those are our equations, those are our assignments. All 3 assignments have been solved. And if you can see, all 3 assignments will have a correlation with what we will be doing today. We've did the substitution here, and this is an expression and an equation. So the next step is to our lesson at hand today. Simple inequalities involving addition and subtraction. Simple inequalities involving addition and subtractions. This is what we will be doing today. We will be solving inequalities that involve addition and subtraction. Now, the objective of the lesson is, by the end of the lesson, or by the time we are through with this lesson, we should be able to solve one-step inequalities using addition. We should be able to solve one-step inequalities by adding. And also, we should be able to solve one-step inequalities by subtracting, by using subtraction. By the end of the lesson, or by the time we are done with this topic, you should be able to solve one-step inequalities by using addition and by using subtraction. An equality is a mathematical sentence that uses symbols. Symbols such as, we have the symbols there, less than, that's the first symbol. We have the less than symbol. And the second symbol is less than or equal to. Less than or equal to. Less than or equal to. We also have greater than. We have a greater than symbol. And we also have a greater than or equal to. Greater than or equal to. These are 4 inequality symbols that we'll be using very frequently as we go along. And we are going to use these symbols to do our graphing as well in the long run. But in the meantime, let us talk about these symbols here. We have the less than symbol. It is called less than. So many a times students confuse the less than and the greater than symbol. They confuse them by interchanging them in various positions, wherein you're supposed to write the less than, students will be writing greater than because they confuse these 2 symbols. Now we can use our body parts so we can easily remember these symbols. Now the bending of the right arm, like this, represents greater than. Or we can start with the less than as it is at the top of the board there. Bending of the right arm like this, the left arm, sorry, represents less than. Okay? Likewise, the bending of the right arm as well also helps us remember our greater than, as you can see on the board. Okay? We can also use our hand using our thumb and our pointing finger here. By doing this, what can we see? Very similar to the less than sign there. Okay? Using your left hand, using your thumb and your pointing finger, you can easily create your less than sign using your left hand. In the same way, using your right hand, you can also create your greater than sign. As we can see here, by using your thumb and your pointing finger, you can easily create your greater than sign. And I think we all have this body part. We can easily use our arm, our right arm for greater than, and our left arm for less than. What does these symbols mean? What do they mean? As we discuss here, we know this is less than, and we know this is less than or equal to. We also know this is greater than, and this is greater than or or equal to. Now, these are not the only statements peculiar to this. There are various statements that we can use. Like you can use smaller than for less than. You can use bigger than for greater than. You can use at least for greater than or equal to. You can use at most for less than or equal to. At most, at least. You can use not more than and not less than as well. So the statements that we have here are not the only statements that we can use to make the meaning of the symbols that we have here. Now we should remember one thing when we are dealing with inequalities. Open circles means that number is not included in the solution set and is used to represent greater than or less than. That is the open circle. In other words, the open circles can only be here and here. Can only be for greater than or less than. That's the open circles. And the closed circles also can only be less than or equal to or greater than or equal to. In a nutshell, the open circles is not included. The given number there is not included. And in the closed circles, the given number is included. Who remembers how to solve an algebraic equation? Because algebra and inequalities have a very big similarity. In fact, their only difference is the equal sign and the inequality sign. So the way you use to solve the equation is the same method that we will use to solve your inequalities. Now here is an equation now. X plus 3 equals to 13. X plus 3 equals to 13. Now we want to isolate our variable x there. How do we isolate it? By subtracting 3 from both sides. We subtract 3 from the left hand side and subtract 3 from the right hand side. We have x plus 3 equals to 13. In trying to isolate our variable here, we subtract 3 from both sides. And we'll end up having x is equal to 13 minus 3, which is 10. X is equal to 10. In trying to prove our answer, whether it is correct or wrong, we substitute the value of x into the equation. X plus 3 equals to 13. Now, if our x is 10 now, plus 3 is equal to 13. 10 plus 3 is 13, which is equal to 13. This shows that our answer is very, very correct. Now, solving one-step inequalities is much like solving one-step equations. As I said previously, you use the same method. The method that you use to solve equations is the same method that you use to solve your inequalities. The second point is to solve an inequality, we need to isolate the variable using the properties of inequalities and inverse operations. And this is the same way we did when we were solving our one-step equations. We make sure we isolate our variable by using the inverse operations. To find the solution, isolate the variable, like I said. And now remember, it is isolated when it appears by itself on one side of the equation. It is isolated when it appears to be on one side of the equation. When the variable is alone on one side of the equation. That is this time we say the equation, the variable is isolated. Let us solve the question on the board together. greater than x plus 6. 12 is greater than x plus 6. Earlier on, we discussed that we should isolate our variable, and the only way we can isolate our variable by using the inverse operation to undo the 6. We have a positive 6 here. The inverse of positive 6 is negative 6. Hence, we've subtracted 6 from the right. We must subtract 6 from the left. So 12 minus 6 is 6, is greater than 6 minus 6 is 0. So therefore, we bring down our x. We have 6 is greater than x. And this is the same as x is less than 6. Now, step 1, since 6 is added to x and subtraction is the inverse operation of addition, like we did, we subtracted 6 from both sides of the equation to undo the addition, and then we end up having 6 is greater than x, which I said is the same as x is less than 6. Now, another step here in trying to prove that our 6 is not included. Now, check the computation. Substitute the endpoint of 6 for x. The endpoint is not included. That is, it's an open circle. Since x is less than 6. 6 is not included. But let us see if we include 6 now, whether we will have correct inequality. Now, we have 12 is greater than x plus 6. Including the x means making the x to be 6, which is 6 plus 6. We have 12 is greater than 12. Is this a correct statement? Is 12 actually greater than 6? 12? No, 12 is not greater than 12. But why did we have a 12 here? Because we have included 6. And 6 should not be included. 6, the end point is 6, should not be included. Meaning any number that is less than 6 is inclusive. So in including 6, we definitely make our inequality to be wrong. Solve and graph. We will be solving the inequality and be graphing it at the same time after solving. The inequality we have there is k plus 3 is greater than negative 2. K plus 3 is greater than negative 2. K plus 3 is greater than negative 2. Let us solve this together. As we did previously, we would love to isolate our variable by using the inverse of addition there, which is subtraction, subtracting 3 from both sides of the inequality. We bring down our k as 3 minus 3 is 0. We have k is greater than negative 2 minus 3, negative 5. That is the answer to our inequality. K is greater than negative 5. This is one part of the question, that's the solving part. We have to represent our answer on the graph. Now we have to draw our number line. In drawing the number line also, the 0 is one of the most important parts of the number line. The 0 should always be shown. And the given number also should also be shown. For the fact that you have greater than there, knowing that negative 5 is not included, so we should have open. On the left, we have our negative number. as we are dealing with negative 5, the number there is negative 5. So therefore, our most important number here is negative 5. Okay? We can show negative 1, negative 2, negative 3, negative 4, negative 5. You can go along here up to 5. But hence we have our 0 and we have our given number. These are the two most important points on our number line here. We have our open circle here because negative included and is going. 5 are all greater than, at the right of negative 5 are all greater than negative 5, starting from negative 4 onwards. So it doesn't matter where your arrow stops. It can go as short as here and it can move as long as you can. But so long it is pointing into the right direction, that is what is important here. The importance is on the direction it is pointing, not how long or how short it goes. We have another one, solve and graph. Our question is b minus 9 is greater than or equal to 2. R minus 9 is greater than or equal to 2. That is the question at hand. R minus 9 is greater than or equal to 2. Now we are solving for R now. We must isolate the R, meaning R should be on one side of the inequality. And in doing so, we have to apply the inverse operations here by adding 9 onto both sides. By adding 9 onto both sides. By doing so, we'll have negative 9 plus 9 is 0. That cancels. So R is greater than or equal to 2 plus 9 is 11. 2 plus 9 is 11. Okay? We have R is greater than or equal to 11. Now we have solved the inequality. It's left with the graphing. Let us graph our inequality here. We must show the 0. It is so important to always show the 0. The 0 must be shown. And all the other numbers also, if you want, you can show them. But the most important number here is our 11. You can show 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now let us look at the inequality sign here. We have greater than or equal to, meaning the 11 is inclusive. In doing so, we know that our circle should therefore be a closed circle. Okay? We locate our 11, and knowing that the circle should be closed, and also knowing that the inequality is talking about numbers that are more than or equal to 11. By looking at your graph and looking at all the numbers that we have here, you automatically know that the numbers that the graph is referring to are all at the right side of 11, or at the left hand side of 11 this way. These are numbers that are all more than 11. But this time around, it is talking about 11 inclusive. These numbers are either 11 or more, meaning at least 11. 11 should be the lowest number. The rest should be more than 11. For the fact that 11 is inclusive, we must close our circle here. Our next question says again solve and graph. We have 9 is more than or equal to W plus 4. I use more than or equal to, as you can use greater than or equal to as well. Okay? So we have 9 is greater than or equal to W plus 4. Again, let us solve this by isolating our variable here. Our inverse here is a -4, -4 from both sides of the inequality. This will cancel out. We have 9 minus 4 is 5, is greater than or equal to W. 5 is greater than or equal to W. We draw our number line straight on, not to forget our 0. Knowing that 0 is very, very key here. It is so important because the 0 tells you it is in between the difference, the midpoint of the negative and the positive numbers. As we have our positive numbers at the right hand side of 0 and our negatives at the left of 0. So we have our 0, and then we can locate our 5 here as well. Okay? Because we have a greater than or equal to sign here, knowing that this 5 is inclusive. The 5 should be included. Because greater than sign, our 5 is included, and then it points the same direction as to where the sign points, also knowing that all the numbers ahead of 5 are greater than 5. Because 5 is included, therefore, which is why we have the closed circle here, it is less than, more than, or equal to 5. We have a question here. Which graph is the solution to the inequality below? We have an inequality given. The inequality that is given there is 2 is less than s plus 8. And we have given 3 graphs. Let us see which of these 3 graphs is the solution to our inequality. We have 2 is less than s plus 8. First, we need to isolate our variable. How do we isolate our variable? By using the inverse operation of addition here, which is going to be subtraction. So we subtract 8 from both sides. In doing so, we'll have 2 minus 8, which is -6, is less than s. 8 minus 8 is a 0. So the question, the answer to our inequality here is -6 is greater than s. This is the same as, is less than x, this is the same as s is greater than -6. The solution to our inequality is s is greater than -6. S is greater than -6. Now look at these three graphs that we have, the 3 options that we have. The first one included the 6, and here the 6 is not inclusive. That disqualified it. And the second one also included the 6. That also is disqualified. The 6 is not included, and therefore it shows the graph that we're supposed to be having here. We have our 0 here, and then we have -6 somewhere here. And the graph, the question is telling us that 6 is not included, so therefore we should have an open circle. Okay? Having an open circle tells us what? 6 is not included. Okay? So therefore, if s is greater than -6, x is greater than -6. As we have here, as 6 is less than s, so therefore s is greater than -6. All right? So which is why our inequality graph will be something like this here. Our 6 negative 6 is greater than S will be our last graph. That's the fourth one. As you can see, if you want to interpret this graph here, the last graph here, which is D, is the correct one. All the digits that are on the right hand side of 6, negative 6, are all greater than 6 from negative 5 onwards. Don't be fooled by the number 6. In negative numbers, the smaller the number, the bigger its value. So therefore, negative 5 here is more than negative 6. From negative 5 onwards, all the numbers after negative 5 are all greater than negative 6, including negative 5 as well. We have another one. Which graph is the solution to the inequality? Which graph is the solution to the inequality? The inequality there we have is negative 6 plus b is less than or equal to negative 4. Negative 6 plus b is less than or equal to negative 4. Now let us solve this graph as well. Negative 6 plus b is less than or equal to negative 4. Let us see which of these graphs will satisfy our inequality. So therefore, I will be leaving this one with you as an assignment. Come next class, we shall solve this before moving on to whatever we will be doing. Of course, we will be continuing. And another one like this, which graph is the solution to the inequality negative 5 is greater than or equal to b minus 2. This 2 will be done as an assignment, and we'll be doing the corrections when you come in our subsequent class. I thank you so much.